Hello guys, it's me Eva and I hope you're doing well. Today we'll be going over the water and carbon cycle within part 1 and part 2 of your revision. So stick around and let's begin. So first of all, we're going to be talking about the system approach and we're going to explore inputs, outputs, stores and flows that operate within the water and carbon cycles. For the system approach, this is the core frame that you have to use for your revision. First of all, you have to be able to analyze inputs and outputs, flows and stores within the water and carbon cycles. So, for example, for the water cycle, we got inputs such as precipitation, and we got outputs such as evaporation. And for the carbon cycle, we have input from photosynthesis and output through respiration, decomposition, and combustion. For stores within the water cycle, we have our largest store being the ocean. We have glaciers, rivers, atmosphere, groundwater, interception, and rivers, and many more. But for the stores within the water and carbon cycle, just remember there is a time frame within which we have our water or carbon stored for, such as maybe glaciers, we store water for thousands of years, maybe rivers, we store water for like a few weeks. And then for the flows, you want to think about processes which usually drives the flow from input to our output. For example, the process of transferring water on the surface into the ground will be through infiltration, and that is where we get the flows of water going to our different stores. So from the surface store, we go into our groundwater store. Hence, you can use flows and processes interchangeably if you think about it, because the flow of something is achieved through the process of something. So the flow will usually allow us to go from one store to the next. And for our boundaries, it is the limits within the system. As you can see, I have inputted my class note into here, and I just want you to be aware that you can go over your class note, highlight stuff that you think are key words for your system approach, and also just to help you visualize and analyze your work. In terms of defining what a system is, it can be described as a process or a collection of processes that transform inputs into outputs. And for our boundaries within our system, it can go under different properties such as elements, attributes, and relationships. Let me quickly go over what these properties mean. So for elements, we're talking about what make up the system, such as atoms, matter, like sand, like raindrops. And when we talk about attributes, we're talking about the characteristic of the element, and that element can easily be perceived or measured. For example, we can measure the temperature, we can measure the mass of something. And when we talk about the relationship, we're talking about the link between the attribute and the element and the processes that occurs to cause an effect within one or the other. Overall, we use a system approach as a model to help us understand and predict impacts within the system. As you can see, system can also be classified within these common characteristics like inputs, outputs, stores, flows, and boundaries. And I'm just gonna explore what these means for you. So inputs and outputs, you're talking about matter slash energy that are coming or leaving the system. And when we talk about store, we talk about matter slash energy that builds up within our system. So when we store something, we usually accumulated. So when we talk about flows, we're talking about matter slash mass within the system that is usually being moved from one store to the other through processes, as I've explored before, like infiltration, and then the boundaries is the limit within the system, as we've also explored previously. Okay, guys, remember that in terms of water and carbon cycle within a global scale, we can't have any more water or carbon that is coming in or leaving our Earth as a system. But for our water cycle on a local scale, we will say it's an open system in terms of the drainage basin. I will now dive into the components that make our open and closed system. So for our open system, we can have both matter and energy leaving our system. And for closed system, we can have mass or matter leaving our boundaries of the system. Remember, it is only energy that can move in and out of our closed system. And then when we talk about isolated system, it means no mass, no energy can enter our system, and that is usually rare. So don't stress about that. Mostly, be aware that for our global scale of our water and carbon cycle, they are closed system, but for our local scale, it is an open system for both water and carbon cycle. When we talk about dynamic equilibrium, we talk about the balance of inputs and outputs within our system, and any changes that try to alter this balance will usually occur via feedback processes, either negative or positive feedback. Think of negative feedback as the neutralizing effect. For example, let's say we have high levels of carbon dioxide within our atmosphere. We can plant trees to absorb more of that carbon dioxide and lead to a reduction in the atmospheric carbon, and this will cause a cooling effect. And then we are back to neutralizing the effects of our high temperature. On the other hand, think of positive feedback as catastrophic. It's something that is not good within our system. It makes the effects of our system worse. As a result of global temperature rise, we will have increase of snow melt within our cryosphere, and that water will be massively directed to our hydrological cycle, which will have a huge disruption within the equilibrium. And in the meantime, the high global temperature rise will prevent snow from forming and accumulating water within our cryosphere. So our positive feedback sort of make the effect worse. We do not result to a solution. Only the negative feedback will counteract the effect of our positive feedback to regain equilibrium within our system. Here is an outline of how you can approach four markers for the system approach for your water and carbon cycle. So for water cycle, you may want to highlight if it's a closed or open system, and then you state what the inputs are, and then you state what the outputs are, and then you back it up with a fact or you explain it forward. Also, you may also find it easier to write four separate bullet points talking about the system approach if that suits you. I would personally go by saying the water cycle is the closed system on a global scale, and we get inputs of precipitation into our system. For example, the Amazon rainforest receives around 2,500 millimeters of rainfall annually. Finally, we get outputs of evaporation. Here is the same or similar outline that I've also used for the carbon cycle. So maybe you may say we have carbon being inputted into our atmosphere from combustion, and then give an example. And then you may say the Amazon emits about 500 million tons of carbon annually from wildfires. And then you may repeat this again for maybe the intake of carbon from photosynthesis or ocean sequestration, and then give a fat saying 25% of anthropogenic CO2 is absorbed by the ocean. The major source of carbon within our water and carbon cycle links perfectly with the system approach, so I've added it on to this video. So after watching this, you can go back and revise for both, and let's dive into what you should be aware of in terms of the major stores. Firstly, know that the major store of water are within our hydrosphere, and it's about 97% of all global water. And then for carbon cycle, it is within the lithosphere, which stores about 99% of Earth's carbon. Lastly, make sure you are aware of how we transfer either water or carbon between the different spheres. In terms of the system approach, you'll be talking about processes such as photosynthesis, combustion within the carbon cycle, or the other two processes for the water cycle would be precipitation and condensation. And then you want to know how these two key processes will drive the changes within the water and carbon cycle over time and space. If you are struggling to understand how this is going to work, stick around for the next video where I'll be talking about the key processes within these cycles and how these could have an effect upon their stores over time and space. That's it for today. If you really found this useful, make sure to like, comment, and subscribe. And don't forget to share with your friends so that they can also benefit. Okay, take care, guys. I'll see you in the next video.